All right, I think we are live. And as you know, I'm Don Johansson. At the Institute of Human Origins here in Tempe, Arizona, at Arizona State University. And you can see a cast of characters behind me. There's a chimpanzee skeleton up there. There are some human skeletons in the corner just over there. And then there are a whole bunch of skulls. Of course, one of the things that we love to have are lots of skulls of these different species. And today, in this hangout, we are going to address some of the questions that have been sent in. And I must say that some of the questions are incredibly extensive and very intriguing. And we won't be able to answer all of them. But I brought some friends along here so we can address some of that. And we can start right off with Kenyanthropus platyops, which, as you remember, means Kenyan man. We seem to have a problem here with lighting. But you know that this was a specimen, 3.5 million years old, that is very crushed and distorted. Some people think that this belongs to Australopithecus afarensis. I'm not totally convinced one way or another on that. I think we do need to see a virtual reconstruction of this specimen and where it fits in. But if it is indeed different in a different genus, in a different species, it's the only species in the genus Kenyanthropus, meaning Kenyan man, and platyops, flat-faced man. It is a unique genus and a unique species that was named, as you know, by the discoverers Mie Veliki and her team that was found back in 1998. If it is indeed verified to be a different genus or a different species, it would suggest that between 3.5 or between 3 and 4 million years ago, Lucy's species, afarensis, wasn't the only species or lineage of hominin. So that would be important. That would be important to determine whether or not there was another lineage of human running in parallel with afarensis. As you know, afarensis was named way back in 1978, and fragments of it were known much earlier but unidentified. And people have looked and looked and looked. We've looked at Hadar, and between 3 and 4 million years, we have only a single species afarensis. I would not be surprised if there is more than one lineage, but we're probably going to need a little more evidence. And with a single specimen like this, it's very difficult to put this on a family tree and to try to understand what it's ancestral to. It's one of those enigmatic fossils about which we'd like to learn a lot more, and certainly to discover many more specimens. As you know, we have 400 specimens or more of afarensis, so we have a good understanding of its geographical distribution, of sexual dimorphism, of its detailed anatomy, and so on. So for the moment, we have a single specimen that is well dated, unlike the recent specimens, say, from South Africa, Naledi, where we have lots of specimens, but we don't have a geological date on them. So you can see how sample size, as well as chronology, are terribly important when trying to fit these things into some sort of an evolutionary framework or family tree or phylogeny that we will talk a great deal about somewhat later in the course. Now, here is a classic Australopithecus africanus with a very flat subnasal area with fairly large teeth. There are no teeth. This is Mrs. Ples, but we have lots of specimens from Sterkfontein. It doesn't have many of the features in the back of the skull that afarensis would. So here is an afarensis skull. Just here, this is a male afarensis skull. You can see that the subnasal area is actually convex this way as well as this way. There are differences in details of the teeth. There are differences in sutures, like an asterionic notch, and so forth and so on. But there are many, many differences, and I think you can see that while these have many similarities, of course, They're variations on a single theme, but clearly they're separate species. And what I thought I would do, or my TA and I, is to come up with a little add-on to the course that will really list the detailed differences for those of you who are interested. Someone is very interested in a side-by-side comparison of Australopithecus afarensis and a side-by-side comparison with Africanus. And when I announced afarensis in 1978, there were a number of people, particularly the late Philip Tobias, who thought that this was just simply an East African version of the South African Australopithecus africanus. I delivered a paper and did more or less a side-by-side comparison. We compared traits and teeth and bones and cranial capacity and anatomy or morphology of the skull. And if there are a significant number of differences, obviously they must belong to a different species. Species is a concept I know that all of us grapple with, and we'll talk about that a little bit more. But we have done this, I think, already in some part of the course, comparing them side by side with features. And I think maybe we should post one of the important papers that we published back in the 80s. Tim White and I did extensive comparisons of afarensis with its purported close ancestor, or not ancestor, relative, Africanus. And I think we should post that paper. And for those of you who are really interested in delving into the details, which are usually considered, I went over, I think, quite a few of them in my lectures on afarensis, but for those of you who are interested, and I'm so happy that people are interested in getting more details of this. This is normally taught in a seminar course or an upper level course or a graduate course where we go into great excruciating detail on all of these various aspects that distinguish these fossil species from one another. But posting a couple of papers, I think, might be very useful to you. Someone's written in and said, is it possible to identify some disease or pathology in the discovered fossils of afarensis? Well, in afarensis, in Lucy herself, AL288-1, there is a little vertebral lipping. There's a suggestion that she might have had some kind of arthritis or something like that. But generally, unless a disease affects and influences bony anatomy, it's impossible to tell if these early hominins, particularly Australopithecus and so on, had suffered from any diseases. If they had suffered from something like rickets, you would see deformation in their skeletons and so on. But there is one partial skeleton from Lake Turkana, which shows extra extensive bone growth on all of the long bones, the limb bones. And it has been suggested that it's due to hypervitaminosis A, which is getting too much vitamin A, which prompts this kind of secondary growth. So remember that our samples are pretty small, and sampling the populations of the past, most individuals that we sample are, quote, normal. They show a normal anatomy. We see some dental diseases, not very much, but sometimes there's resorption of the gum, for example, that's reflected in the bone, and it's an abscess, for example. And that's why when your dentist tells you to floss your teeth and brush your teeth on a regular basis to keep bacteria from building up and to keep blood flowing and stimulated with moving through the oral cavity and so on, that you want to do that because you don't want to develop any sort of bony diseases in your mouth, because if it does develop into an abscess, it could cause major infections and eat away at the bone. So you sometimes see that in some of these early hominins. Let's see, what else was then hang out? Two species, all right. to whether they're modern apes or modern humans. I mean, apes do suffer from arthritis. Humans suffer from arthritis. So I don't know if we would be able to really distinguish ape-like diseases from human-like diseases. For example, simian virus, which we see in humans as AIDS, is something that you would not see reflected in the bones. And because there are no genes left, there's no DNA left in these things, we can't look at that or remains of blood that might have indications of those diseases. But bony diseases, yes, we can detect them in some of these. And there are people called paleopathologists who deal more specifically with trying to understand disease in these early hominins. Let's see, what's our next question we want to address here? I wanted to, someone's written in and asked, said that they followed the discoveries of the Leakeys and myself, and I presume other paleoanthropologists, since the early 70s. And beginning in the early 70s, as I think I've said in the course, this was an explosive time for our understanding. I think we're undergoing that kind of game-changing understanding with Neanderthals. As you hear, later in the course, we'll hear more about Neanderthals every single day, every week for sure. There's a new article about Neanderthals. You know, could they create art like the discovery of these hash marks in Gibraltar? What kind of cooperative behavior did they have? If they did interbreed with us, what were the positive sides and the negative sides of that? What did they give us? Did they give us certain genes that made us immune to certain diseases, and so forth and so on? So I think today we're looking at a much deeper understanding of later parts of human evolution, like Neanderthals and probably early sapiens. But in the 70s, this was an explosive period, sometimes called the golden age of paleoanthropology, when major discoveries were being made in geologically datable contexts associated with tools, et cetera, new species being developed. So the question is, does the choice of excavation site influence the fossil record? Well, the choice of the site, if it's an important site, when I visited Hadar in 1972, there had been no human ancestor fossils found in the Afar Triangle, which, as you know from this course, is a fairly large geographical region, about a triangle about 600 miles on the side. And yes, I chose specifically the site of Hadar, where Lucy was found, because it was so very fossil rich in all kinds of animals. And I suspected that this was the kind of environment, kind of world, past world, that was like a game park in Eastern Africa. And part of that faunal collection must have been made up of early humans. And I made the discovery of the knee joint that we've talked about quite a bit. So yes, it does. You want to choose places where you think you're going to find extensive fossils that will have something new to say about the human evolutionary record in various parts of the world. They are, and a very interesting part of this question says, we're finding individuals adapted to specific niche ecosystems and terrains. And I think that's becoming more and more interesting as we think about the geography of Africa. If you look at Africa, it's very long from north to south. And there are a great number of different kinds of ecosystems, from snow on the top of Kilimanjaro to deserts that rarely ever even see rain. So there are environments at sea level, there are tall mountains, there are major rivers. So you have an enormous amount of variation from North to South Africa. And I am beginning to think more and more that what the window we have open to us with the Great Rift Valley in Eastern Africa allows us to see what was going on in and around the Great Rift Valley. If we were, as this question says, if it were possible to find fossils from West Africa and other humid forest regions of the globe, would you expect them to reinforce our understanding of current theories, or would they just as likely throw a spanner in the works? Well, I've hypothesized, as many of my colleagues have, and I've mentioned in this course, that geology is really what opens up the past to us. In southern Africa, you have those subterranean caverns where animals and hominids fell in and became fossilized and preserved. In East Africa, you had lakes and rivers that were rapidly depositing because of the spreading of the Rift Valley, and now with erosion, they're resurrected for us to go out and try to discover. I suspect that if we could look back in Africa 2 to 4 million years ago and get fossils from other places, we would find out that there were probably a great many more species of human ancestor than we have on hand today, which would make the tree much bushier, with many more species on the human family tree. But because of the acidic soils and so on, and other aspects of taphonomy, which is the study from the death of that individual to its appearance in the lab, what are the processes that influenced all of those discoveries, and the fact that they're there for us to discover, we would probably discover quite a number of different species. I don't think it would necessarily throw a spanner in the works, but it would allow us to look at the great diversity of early hominids, many of which probably didn't evolve into anything but died out. If we go back to the age of the apes in the Miocene that we've spent some time talking about, you had tens, maybe hundreds of species of different kinds of apes. Today we have an impoverished sample. We have bonobos, chimpanzees, and gorillas in Africa, and the upright ape humans. So that was a time of extraordinary diversity in apes that was whittled down and is still being whittled down, because many of these apes are in danger of extinction or disappearance, particularly things like orangs in Southeast Asia. And it is very possible that groups of early hominins wandering into different places and experiencing different natural selective forces would have evolved in their own direction. I think that Homo naledi, as recently announced, is probably one of those groups of early hominins that was sequestered in the cul-de-sac of southern Africa. And because of different environmental conditions and challenges and so on, evolved in their own evolutionary direction and probably ultimately went extinct. Another good example of that would be Homo floresiensis, the hobbits, as they are sometimes called, in Southeast Asia. Last summer, I had the opportunity of going to Flores, to Liangbua, and seeing the site where Flores was found, Homo floresiensis, the hobbits. And I think a small group of early hominins wandered off and got trapped on that island or in somewhere in the Malay archipelago and evolved in their own evolutionary direction. So it would be interesting to see what other kinds of things are cropping up. I was asked as soon as the lady was announced by many reporters, do you think this is a new species? Well, yes. I have no objection whatsoever that it's a new species. And it wasn't surprising. I think the more we find, the more we will see the diversity. I mean, after all, if you think back to what I spoke about when I was a young student at the University of Chicago and started my paleoanthropological career in 1970, we had a handful of species. Today, we've got lots of species, all the way from Sahelanthropus, if that is indeed on the human line or not, or as an ape ancestor, that's still being debated. And you've had to learn a lot of things: Australopithecus africanus, afarensis, Homo naledi, Australopithecus sediba. So there's been a real explosion of numbers of species. And I think we should not be surprised by that, because different environmental conditions produce different kinds of animals. So I don't think it would throw a spanner in the works. It would show us how creative natural selection can be. And we happen to be the one that has made it through all of these trials and tribulations of evolutionary change and climatic change and so on. Another question, from what I have learned from the course, Lucy was more of an ape than a human. Some people actually have suggested that she's virtually the ape that stood up, but we know we can go back even deeper in time to things like Ardipithecus from the Middle Awash, which still has a very large divergent great toe. Was that an ancestor to Lucy or not? I mean, we are always trapped, and you have to really think about this in this unilinear thinking that just because we find something, it has to be on the line to something later. Well, that's not necessarily the case unless you can make connections, and I'm going to address that in a minute here because someone asked about that. But it shows this great diversity and this plasticity and this creativeness of natural selection. So what makes Afarensis a hominin and not an ape? Well, it's walking upright. It has that unique feature, and it's walking upright in a very distinctive, familiar way. If you, as I say in class, if you walk on the beach and you look back at your footprints, Lucy's species would have left that sort of thing. But from her brain, very small, she was only about 380 cubic centimeters or something or other. So very small, very ape-like. She had, and you see this, of course, very clearly in the male specimens, which are much, much larger than the female specimens. This is a female Afarensis here. This is a male, and you can see how much bigger a male is. But they did have very projecting or prognathic faces. If you take a line just here, you can see how much of a face is out there, okay? There's a lot of face out there. If you look at somebody who might be sitting next to you or you look in the mirror, we have very flat faces, okay? So I forgot where I was, actually. So that Lucy was not necessarily an ape. She still had many features that connect her with an ape ancestry. So that it's the idea that I spoke about very early in the course about common ancestry, that there was some kind of a common ancestor, more ape-like than human-like, that gave rise to the African apes and us. So I think it'd be a misnomer, really, to say that she's more ape-like than human-like. One of the startling features and distinctive features is upright walking, of course. And then when you get down and you look at the nitty-gritty, as we did, we looked at particularly premolars in the lower mandible, where in apes, they have a single cusp, and in a certain percentage of Afarensis, they have a single cusp. But if you feel the inside of your premolars or your bicuspids, they're called bicuspids because there are two cusps there. So you're looking at something that has certainly retained ape-like features, but it is obviously on the human family tree because it does possess things like upright walking, for example, which is a very unique adaptation that we've talked about, I think, in great detail. Now, I showed the clip of the movie. Remember, this is Hollywood. With Scarlett Johansson going back in time and meeting up with Lucy. Her name is Lucy in the movie. And this is part of the same question. And what's interesting about it is that there's the reference to Brian Richmond, who's now curator at the Physical Anthropology at the American Museum of Natural History. He thought that there was evidence in the wrist, particularly in the forearm bones, of knuckle walking, that these creatures were walking on their knuckles. As we know, chimps and gorillas do that. That's a specific mode of locomotion. But it has been shown that the evidence is just not there for knuckle walking. Now, In the movie, and whoever wrote this question, I congratulate them for being so observant and seeing that movie and seeing that there was a clip of her knuckle walking. Well, they really didn't knuckle walk. We know that Afarensis did not knuckle walk. The very distinctive features, particularly in these metacarpals where there's a little ridge here, are absent. And we have enough hand bones, enough metacarpals to look at to show that the adaptations for knuckle walking were certainly not there. But in regard to this question, I wanted to mention that there is a museum in, I believe it's in Kentucky, which is called the Creation Museum. It's a creationist point of view. I've never been there. I intend to go sometime. But it's astonishing how they have recreated and reconstructed the Lucy skeleton on all fours knuckle walking. And it's just blatantly wrong. And it's a shame that this kind of misinformation is being perpetrated in a museum like this. So knuckle walking, we talked a lot about it. I'm not going to talk any more about it. But certainly Lucy was not a knuckle walker. There's no evidence that any of these early hominins were knuckle walkers, Ardipithecus, for example, and so on. That knuckle walking doesn't show itself in any of these early hominins. Okay, where are we going to go from here? Someone wrote in how interesting it is that we can distinguish males from females, and I think it's very clear that these two skulls of Afarensis are very different in size, but in terms of anatomy, they're really astonishingly similar. If you look at them like that, so that's a good view right there. You can see how they're virtually identical. Just one, the male, is a larger version of the female. But it's an important consideration when you are making comparisons that if you have a potential new species, you should be aware of perhaps sexual dimorphism, that you should compare males with males and females with females. But here, with such virtually identical anatomy, except for size, and look at the details of that brow, for example, how similar they are. And there are so many similarities in these two creatures that the most parsimonious and acceptable view of this would be that the smaller individuals are females and the larger are males. We have somewhat reduced sexual dimorphism in modern humans with a lot of overlap, but as I may have said, we are domesticated animals. These were creatures that were living in the wild and had reasons for being very large as a male, for protecting the group, for example, and reasons for being very small in females because of their reproductive demands that were placed on them. So it's very important not to say, oh, well, as many people did when Afarensis was first announced in the late 1970s, they said, well, the big ones are probably a different species from the big ones are different species from the small ones. And there were and still are a number of very few paleoanthropologists who think that there are two species at Hadar. We think that there's one species and that variation reflects sexual dimorphism to a very large extent. So it is important to keep track to compare like with like, for example, and look at the details. You'll find in both the males and the females the same distinguishing anatomical features that define the species itself, okay? So it's very important to do that. And also it's important to compare ages. You don't want to compare this, which is the original Tong child that was announced in 1925 by Raymond Dart, that grew up into a much more projecting face, some feature that develops later in life, a prognathic face. And this is Africanus. This is Mrs. Ples, Miss Strickfontaine. So you don't want to compare necessarily these two an immature, maybe 3-year-old, with a fully developed adult. So it's very important to make sure that you're comparing like ages and that you're not looking, for instance, there are some who think that in Australopithecus sediba, which is considered to be a different species from Africanus, that maybe some of the features that are missing that are distinctive of Africanus in adults are missing from sediba because it was an immature specimen that they were looking at. And how do we do that? How do we judge the ages of these fossils? Well, by the closures of sutures on the tops of the skull and the sides and so on. And in the base of the skull, long bone growth we've talked about, that you take a femur, it has a growth plate at the top and a growth plate at the bottom. And with skulls like this, it's obvious that you're looking at a lower jaw. This is the lower jaw of the Tong baby, the Tong child, the type specimen for Australopithecus africanus. And what you're looking at here are immature or milk teeth. These are baby teeth that will fall out. We call them deciduous teeth, like trees that lose their leaves are deciduous. They drop their leaves. In this case, you have the first milk molar and the second milk molar, and these will be replaced by the bicuspids or the premolars. And you have the eruption of the first adult permanent molar, which is this molar right here. And you can look at the teeth and say something about the potential biological age of specimens like this and know that this is an immature specimen. And in fact, one of the earliest criticisms leveled at Raymond Dart by a number of people in Great Britain was that he made this diagnosis of a new species and a new genus on the basis of an immature specimen that might, if it had been a grown-up, would have grown up into an ape. So, because many of the features that distinguish apes from us in terms of development of the face, for example, happen later in life. Well, those critics were wrong. This is an immature specimen of an early hominin, which clearly is a different species. So it is, that's a good question, because it is important to compare adult specimens with adult specimens and young immature specimens with immature specimens. And there's a lot of work in the field still to be done on trying to understand the growth patterns from a baby Africanus to an adult Africanus, and as is the case for afarensis. And there are a number of immature baby-like skulls of afarensis, and Dr. Zarestan Aylam-Seged at the California Academy of Sciences is found the Dakika baby, which you may remember, is a baby afarensis, and he is undertaking at the moment a very detailed study of trying to understand the growth from a baby to an adult afarensis. Someone wrote in that they were interested in citizens science crowdsourcing projects. I assume it's something like SETI, the Search for Extraterrestrial Intelligence, that's located in California, where they have incorporated people on computers all over the world to look for some unusual event that might suggest that people are trying to contact some life form out there is trying to contact us. We haven't heard anything thus far, but that's another topic. In terms of what citizens can do for paleoanthropology, a good example, I suppose, is Lee Berger's emphasis in South Africa, spreading the word in his classes and to colleagues and students and so on, that there must be other caves like Sterkfontein and Swartkrans and of course the Rising Star, where these somewhat controversial Homo naledi have been discovered. There were people who were interested in, they were cavers, they were people exploring subterranean caverns, but because they knew of the interest that Berger had in human evolution, and they spotted these fossilized bones, they brought it to his attention and helped participate in that discovery. Um, in the United States, for example, I know there are archaeological surveys all over the country that appreciate it when, say, a farmer or a hiker or someone finds something and relates it to them. In Africa, it has happened in southern Africa, as I said. There are reports that other people have of finding fossils in places like that. But otherwise, I'm not really, and I'm not aware of zoo inverse, which I will look up after this little chat, and thank you for that. But otherwise, I really don't know. I know that we at the Institute of Human Origins here in Tempe, Arizona, are in the process of putting together Ask an Anthropologist, Ask a Paleoanthropologist, which may be a venue for people to actually contribute something to a better understanding of various aspects of human origins. Now, Louise Leakey, who is it's hard to, you need your little phylogeny of the family, but Louise Leakey is Richard Leakey, the son of Louis and Mary, and Meve Leakey, Richard's wife. It's one of their three daughters. And I saw her not long ago in Tanzania, and they are taking photographs of landscapes, and they're putting them online and seeing if people looking at them can actually find fossils in those photographs. Many years ago, I know I took someone on safari, and he said, "Why don't you have these little hovercraft here going along the ground, and you can sit in your nice air-conditioned laboratory and back in Tempe and not have to be out there at 105 degrees every day looking, and do this remotely." And now with drones, that certainly is a possibility. But I think that there's really little substitute for being on the ground. It is a very different perspective, but it is possible that someone could find something on an image that was posted and say, "Boy, that looks like a hominid molder to me," or "That looks like the top end of a femur. I don't know if it's a monkey femur or a human femur, but I'm going to circle this," and send it back to people in Africa who can go out and take a look at the actual site. So there are some possibilities such as that. I think that remote sensing is very important for locating potential sites based on the kinds of rocks. You don't want volcanic lavas, for example. You want lake or river or delta sediments. But perhaps something like that will be possible in the future. So what are my thoughts about the purported stone tools from Lamweki on the west side of Lake Turkana that were announced? Andy asked this question. These are big rocks. When we think of stone tools, we think of things that immediately fit into your hand. What were they doing with these things? What were they smashing open? What were they smashing something open? They are somewhat of an enigma, but it looks like they are deliberately smashing these rocks together. And as I have talked about on numerous occasions, maybe the early stages of the realization that a cutting edge could do something was purely accidental. Maybe like you see chimps in West Africa that are using favorite stones and an anvil to break open hard nuts or fruits that they can't otherwise get into. And during that process, and using bigger rocks, they inadvertently may have cut their finger or their palm and realized in this almost genius moment, this aha moment, that, wow, this cut that. Well, why couldn't it cut an animal skin or whatever? So I've not seen the tools. I'm not an archaeologist. They are found in a context where obviously they had to have been brought in. They were doing something with this. They're very old. They're 3 million plus years old. What were they doing with these huge blocks? I don't know. Is this a unique sole incident? Are we going to find many more examples? This harkens back to some cut marks that have been found on uh, animal fossils associated with Afarensis, like geological time period at 3.3 million years ago. And we have a study ongoing at Hadar where we are beginning to look intensely at every little fragment of bone to see if there are cut marks on them. And this is really a work in progress. But certainly the idea that stone tools only went back 1.8 million years ago and were called Oldowan tools has been shifted significantly back in time. So that's sort of a stay tuned. I think there's going to be a lot more emphasis in trying to understand the earliest tools, what they were doing with the earliest tools, what prompted them to and ultimately begin making these on a more regular basis, and so on. So based on what I know about different field work that's currently going on, what do I envision as possible fossil finds? Well, that's a question that so often is asked of me by journalists. Geez, Don, what do you think you're going to find when you go to the field? Well, I always sort of say the unexpected. And that was certainly the case at Hadar when we found the fairly complete upper jaw of the genus Homo at about 2.3, 2.4 million years. We never expected that. So it's very, very difficult to make predictions, but I would say overall, we should look forward to more fossils, obviously, and probably more species over the next 5, 10, 20 years. And the discoveries of these incredible fossils in Georgia at near outside of Tbilisi, for example. These are extraordinary fossils. Nobody ever expected to find such complete fossils of that age, 1.8 million years, in Western Asia. So people are looking more widely, people are looking more deliberately, people are looking in unique places, and they are finding unique things like Flores, like the lady, and so on. Let's see. Questions I thought. Well, there is a fairly lengthy question which deals really with trying to understand evolutionary relationships. And I'm just going to touch on this briefly because we will later on try to make sense out of the evolutionary relationships between, all these different species that you see on this table, okay? And try to understand how they are related to one another. The most exciting one, I think, right here on the table, is that I bet you all know what that is, right? That's Nutcracker Man from Olduvai. And it has this sagittal crest. It's got massive, what were called nut-cracking teeth, so it was called Nutcracker Man. It's got huge jaws and so on and so forth. And what was its ancestor? Well, it was the black skull that was found. And here is an example of that. And it has the crest, right? Doesn't have teeth, but those are massive roots for massive crushing and grinding teeth. But what's the major difference between this is it's got a very projecting face. the black skull, as opposed to the flat face that you see here in Boise or Nutcracker Man. Now, what does that? It's got a massive crest. It's almost like a keel on the top here that you'd see in a boat. So it had massive chewing muscles. It had big teeth, particularly molars and premolars. Really hard to see the black skull. But it also had a very broad frontal region and a very projecting face. That projecting face is probably a leftover from its ancestor, Afarensis. So you have an intermediate fossil here. So you can begin to trace lineages, as we will talk about later. But this question addresses, what was ancestral to what species, and so on. And we will be dealing with this in great detail. But the question says, is Africanus a possible ancestor of Afarensis? So is Africanus an ancestor to Afarensis? Well, I think you know that the answer to that question, because this is 3 to 4 million years old, and this is less than 3 million years old. So there's no way that that can be an ancestor to that. It has to be the other way around, that Afarensis is an ancestor to Africanus. And we will deal in some detail about that later in the course, and I think you'll all find it interesting that we're trying to put these things together. And what has been so unique and gratifying over the last number of years is that we have found a dense enough fossil record, particularly in East Africa, to see an evolving lineage from something like Anamensis, which was found at Lake Turkana by Miv Leakey, to Afarensis. And within Afarensis, the older ones from the site of Laetoli are a little more ape-like than the ones at Hadar. And now an ancestor to those two branches, the branches of Homo, because we now have Homo at about 2.8 million that have some similarities with Afarensis, and then Homo at 2.4. So Lucy's species seems to be an ancestor to the modern human genus, Homo. And on the other hand, an ancestor to Aethiopicus, or the black skull, that ultimately led to this incredible specialization that we see in Boise. And we will talk about those and talk about how different this was from when I was a student at the University of Chicago. We really didn't have a good understanding of lineages. There were more dotted lines because there were so few fossils, and very few fossils from much more ancient times. We talked about that, knuckle walking, and that one. And there are some questions here that we're not going to answer today, unfortunately, because an hour seems to go by very quickly. All right. Well, what is the one fossil that we still hope to find? Well, I think as you've learned, as we've talked about the hominin fossil record, that it isn't really a single specimen. We want to find larger samples of some of these things, just like Platyops. If Platyops is really a distinctive genus and a distinctive species, you want to find out what the range of variation is in this creature. It's over time, over geography, and so on. So I don't think necessarily it is a single specimen. I think it's a more complete fossil record over time and over geography. And this takes a lot of dedicated field work by a number of stalwart individuals who are willing to, give up the comforts of living in their home, let's say in Europe or the United States or Asia, and going off to remote places, never knowing what and if they will ever find anything. So it's not necessarily a single fossil. It is, and now with genetics, a lot of this work can be done in the lab, for example. The work that's being done on the Atapuerca fossils, for example, showing that the roots of Neanderthals go back 400,000 years or something or other. So it is this multi-interdisciplinary endeavor that kinds of stitches together information from geology, paleontology, paleoenvironments, pollen, anatomy, function, and so on, that is allowing us to sort of flesh out our understanding of the shape of the human family tree, the mode and tempo of human evolution, as George Gaylord Simpson talked about it, and that means a lot of on-the-ground research. Let's see what else we got here. All right, looking at the illustrative reconstructions of various ancestors and relatives, one sees many of them are covered with hair. Well, Afarensis lived in an environment very similar in many respects to some of the apes. Not dense, thick tropical rainforests, but not open grasslands, okay? And since it does have a number of ape-like features, artists who reconstruct these think that they probably had more body hair than we have today. Now, in here it talks about, did sweat glands replace hair? No, not really. We still have the same number of follicles on our bodies that apes do. It's just that the genes regulating body hair growth shut down earlier, so we don't have as dense hair, but there's variation. You see this if you go to say a public swimming pool, for example, with males. Some males are not very hairy, others are very hairy. They have an enormous amount of body hair. So the potential is there, but the trigger, whatever that is, to keep those genes producing body hair, shuts down much earlier. And I think, and most people seem to suggest, that this probably is in certain relationships, something to moving to more open environments where sweat glands now become terribly important for maintaining a low body heat, and the more less hairy surfaces allow the transfer of body heat away from the body. So yes, these are in some ways artists' reconstructions, but there are a number of reasons why we think they do or probably had that kind of hairier body. Species is something that everybody in paleoanthropology gets very wrapped up in, and would argue, are these a new species? Like Homo naledi. Well, Homo naledi looks very much like fossils from Java that are called Homo erectus. Okay, but they're clearly not the same species. There's a significant difference in average cranial capacity. But in addition, if you just look at it logically, the ones in South Africa are not sharing genes with these fossils, the Java man fossils in the Malay archipelago. I mean, geographically, they just never would ever come into contact with one another. So in that case, they're not exchanging genes because of physical distance, geographical distance. And it is always hard to try to understand, how species change, and would you be able to tell if you're right in a period of time where change is going on, if it's changing from one species to another? Are there specimens that will be difficult to put into one or the other category? Well, theoretically, yes. But when it comes to the biological species concept, and this question addresses the fact that, Neanderthals, Denisovans, that we'll learn about, and sapiens all seem to have exchanged genes of some kind at some time in some places. We don't have any genes, well, sometimes they're restricted to very specific geographical regions, for example. We'll talk about that more. But is it possible that interbreeding might have happened during the time of Australopithecus? Well, I think when you see this level of difference, these were very distinct species. This would happen to be in South Africa. This happened to be in East Africa, so they probably never would have met, sort of face to face. But I think they're really so incredibly different from one another. There was no interbreeding going on. Modern, I mean, humans and Neanderthals and Denisovans, as I said, certainly have. But this person says, I've never heard of related species like the cats. In this case, he chooses the lion and leopard, which both live in Africa, right? They never interbreed with one another in the wild. They recognize that there is a reproductive barrier between the two of them, and they never mistake. A lion never goes out and tries to mate with a leopard or vice versa. And getting closer to home, looking at the African apes, for example, in West Africa and other places also, chimps and gorillas regularly intermingle. They are, for some people, they belong in the same, maybe in the same genus, but different species, but they're never seen interbreeding. There are mechanisms that, keep them from interbreeding with one another. So a baby gorilla or a young gorilla, juvenile gorilla, never sees a young female chimpanzee and tries to interbreed with them. There are these reproductive barriers, and remember that those are under very natural conditions. So it is very rare. I don't think it's ever been reported that chimps and gorillas in the wild would have ever tried to interbreed. The second part of this question is, did Homo sapiens have other humans as pets or servants or slaves? Well, I don't think so. Domestication, of course, of pets came much later in human evolution. There's no evidence for this found early on. So I think that, what kind of evidence? We need extraordinary evidence to say that, early Homo habilis had boisei as a pet or something or other. I think they were totally different. But it shows again that so many of you taking this course are really thinking about the subject. That it isn't just, and I know there's a lot to memorize and a lot to remember, and making your way through these tests and exams and so forth, but that you are beginning to think more broadly. I mean, my major goal in this course, as I think I've said, is not to hope that all of you will apply for graduate school at Arizona State University and want to get a PhD in paleoanthropology and go out and find fossils, but that at least you will understand the human career and how we came to be who we are, and how the same powerful paradigm that Darwin came up with, evolution by means of natural selection, has been the crafter of ourselves and how we fit into the natural world. And that we have a tendency when we live in Mumbai or Paris or Singapore or New York, that we are beyond culture, beyond biology, that we are no longer part of the biological world. Well, we are. And the same mechanisms that explain the appearance of every living creature on this earth help understand how we came to be. And that's evident in the questions. We've many, many more questions here, but unable to address those. Our hour is up now, but I want to thank you all for signing in and getting a glimpse at sort of the main laboratory here at the Institute of Human Origins, and to, again, hopefully invite any of you who ever come to Tempe or Arizona to come by and visit this. Go to your local museum, go to the exhibits in New York City and Washington, D.C., and so on. Seeing specimens like these in 3 dimensions, and particularly where you have a place to hold on to them and touch them and feel them, there's no excuse, no substitute for that. So at any rate, we'll end our hour, and I hope that you'll have a wonderful remainder of the course. And it was a treat for me getting to visit with you today. Thanks very much.